The May 2018 AS paper question 12. So part A showed the equation 4 cos theta minus 1 equals 2 sin theta tan theta can be written in the form 6 cos squared theta minus cos theta minus 2 equals 0. So the first thing that we can notice about these two is that first of all we've got cos, sin and tan, and in the answer we've only got cos, so that's what we're going to try and convert to. So for part A we've got 4 cos theta minus 1 equals 2. Sin theta, I can't do much with that at the moment, so I'm going to leave it there. I'm going to call tan theta sin theta over cos theta. So by moving my cos theta over to the other side, I'm going to get 4 cos squared theta minus cos theta equals 2 sin squared theta. Now, I know that sin squared theta add cos squared theta equals 1, so by rearranging that, we can say we've now got 4 cos squared theta minus cos theta is 2 lots of 1 minus sin squared theta. Not sin squared, sorry. Cos squared theta. Now, what we can do is we can expand those brackets. 4 cos squared theta minus cos theta equals 2 minus 2 cos squared theta, and then rearrange. We get 6 cos squared theta minus cos theta minus 2 equals 0. And then we've got our proof there. Part B, hence solve for x is between 0 and 90 degrees of 4 cos 3x minus 1 equals 2 sin 3x tan 3x. Now what we can see is that our part A and our part B are identical apart from the fact that we've got theta being replaced by 3x. Therefore we can say that our equation can be modelled like that. Without theta we've got 3x. So if I were trying to solve that, for part B we're actually going to be solving 6 cos squared 3x minus cos 3x minus 2 equals 0, where x is between 0 and 90. Now the issue we've got here is we don't have consistency. So you can see we've got 3x, we've got 3x, and we've got 1x. So what I need to do is I need to multiply all my bounds by 3 to give me 0, 3x, and 270. And now we've got the same thing in our question and in our bounds, so we can go and start working. Now what I always do is I'm going to say let 3x equal theta, just to make things a little bit easier to work with. And we've got 6 cos squared theta minus cos theta minus 2 equals 0, where theta is between 0 and 270 degrees. Now you've got a quadratic in terms of cos theta here, so you can either use the quadratic formula, you can factorise, you can use your calculator, but you'll get the solutions to be cos theta equals 2/3 or cos theta equals minus a half. And so what we're going to do is we're going to write out the two different solutions for theta, and then we're going to do 2 separate cast diagrams and then compile all our answers together at the end. So if cos theta equals 2/3, we inverse cos 2/3, and we're going to get 48.2 degrees. And if we inverse cos of minus a half, then we're going to get theta is equal to 120 degrees. So cast diagram, CAST, 0, 90, 180, and 270. So when we're looking at this, we're saying we are starting here at 0, and we are finishing here at 270 degrees. And our 48.2 goes in here, and our other 48.2 goes in the cos quadrant because cos is positive. And so our solutions, we've got theta, we start and we hit our 48.2 line, and we go around and we hit our finish line, so we don't actually use the second value at all. Looking at 120, we draw our cast diagram again, CAST, 0, 90, 180, 270. Put our start line and our finish line in here. And so this time we've got 120 degrees, so we're going to be in this quadrant, but we don't want the 120 degree angle, we want the acute angle formed with the x-axis. So from 120 to 180, that's going to be 60. Cos theta is negative here, so I'm looking in sine and I'm looking in tan. So my theta values are going to be starting, I hit my line at 180, take away 60, 120. And then my next line at 180 add 60, which is 240. So my theta values are 48.2 degrees, 120 degrees, and 240 degrees. Now, we did a substitution at the beginning, so this is actually my 3x values of 48.2, 120, and 240, leaving me with my x values of 16.1 degrees, 40 degrees, and 80 degrees, which are all within our